Okay, so this one says, which function has a rate of change of -4 over the interval -2, comma 2? So remember that's the slope. So what we're really saying is, remember that the rate of change is the same as the slope, which the formula for that is y sub 2 minus y sub 1, right? This is an Algebra 1 concept, all over x sub 2 minus x sub 1. In fact, I even covered it with you guys in geometry a little bit. Now, in math, y sub 2 minus y sub 1 is what we call the incremental of y. And this is the Greek. I don't know if you guys remember me going over this with you guys last year, but this is delta, right? So delta means change. So that's the Greek letter delta, and it means change. So we're really saying the change in y over the change in x. Okay, so the rate of change can be called the slope, which is m, and it can also be called change in y, right? That's where the delta comes from, over the change in x. And in this particular case, they're saying that m is equal to -4, but really what they're saying is m is equal to -4 over 1. So this represents delta y over delta x. So one way to find that is I could just go and find delta x. So delta x is, what am I doing to this to get to the next value? So really what I'm doing is I'm adding 1 to get from -2 to 1. Then to get from -1 to 0, I'm adding 1 again. So this number, if the number repeats itself, that is my delta x. So in this particular case, my delta x equals +1. Okay. Now here, my delta y, I'm adding 6. Then I added 0. Then I added 0. Then I added 6. So the delta y changes. So delta y is not constant. It's not the same. So what we're looking for is one of these when I look at delta y, look at delta y, look at delta y, I'm going to have an average change of 4. Okay. This one, and another way you could do this too, the shortcut way, because these aren't all going to be linear, is to take this number and this number and calculate the slope. In other words, I could go in here and I could say 6 minus 6. So I'm going to take this 6 and subtract this -6. Those are my delta y's, right? The y sub 2 minus y sub 1. And then I have to remember that I'm going to put 2, and then I'm going to subtract -2. And so this becomes a plus, and I get 12 over 4, and that reduces down to 3. And it's a +3. And remember, we're looking for something like that gives me a -4. Okay. So if I do that for all of these, I think C is the one, because as I'm looking at this, I'm doing it in my head. So if I let this be y sub 2, and I let this be x sub 2, and then this is x sub 1, and this is y sub 1, right? The slope of C is going to be y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now this is kind of the average, right? Because it says average, right? It says average. So In other words, when I look at this thing, I don't subtract 4 to get from 12 to 5. I subtract more than 4, but I don't subtract as much on the end either. So I'm trying to see what the average would be from the beginning to the end. So this one, y sub 2 is negative 4, okay, minus y sub 1, which is 12, okay, and then 2 minus 2. So you get negative 16 over, this becomes a positive 2. When you minus minus, it becomes a plus, over 4, which is negative 4. So I kind of did that in my head. Now, for time's sake, I would do that process to all of these until I got the right answer. It's just Mr. Adams kind of looked at that and kind of did it in my head, and I thought that was it. How did I do it in my head? I was like, okay, what's the difference? Like on a number line, if I start at negative 4, how many spaces do I move to get to 12? Or if I start at 12, and how many spaces do I move to get to negative 4? Well, it'd be negative 16 spaces. And then to get from negative 2 to 2, it'd be positive 4 spaces. Negative 16 divided by 4, negative 4. So that's how I did that. And I